Imagine you could isolate a single particle of light, a photon. It has no mass and no internal structure. Now, suppose a mirror drops so fast it tries to slice that indivisible photon perfectly in two. Common sense tells us one of two things should happen. The particle bounces off the mirror, or we end up with half a photon on either side. But look at this diagram. This illustrates the actual quantum behavior. A single smooth wave hits the barrier and shatters into an infinite cluster of overlapping frequencies. The vacuum itself reacts. By forcing the cut, the system generates an endless superposition of virtual photons. A photon is a continuous wave of the electromagnetic field. When you introduce an ultra-fast barrier, you drop a guillotine on the mathematical symmetry that holds that field together. To understand why the field rejects this cut, we have to look at the universe as an operating system and track exactly how a single particle moves through three distinct stages of reality. Stage 1 is the unary. Before the mirror even enters the picture, the photon exists in a state of absolute symmetry. It is a pregnant field of pure potential, completely undisturbed. If we map out the Planck level, the absolute basement of reality, it looks like this smooth, pulsating field. Down here, everything operates on a zero axis. There is no specific here or there, and no ticking clock separating before from after. Then comes stage 2, the binary. The mirror snaps shut. In an instant, that infinite, timeless field is forced to accept a hard boundary, a strict left and right, a definite here and a precise now. In 1918, mathematician Noether proved a law that governs this exact collision. Noether's theorem states that every continuous symmetry in nature is strictly tied to a conserved quantity. Symmetry in time guarantees energy is conserved. Symmetry in space guarantees momentum is conserved. The universe enforces this strictly. If a physical boundary breaks a symmetry, the system demands a physical payment. Our mirror just shattered the photon's continuous symmetry across time, space, and phase all at once. This brings us to stage 3, the ternary. The cut destroyed the local symmetry, leaving missing information in its wake. The universe mathematically must balance its books to account for the disruption. First, the mirror broke the symmetry of time. By forcing a timeless photon to stop at a specific instant, we trigger an extreme reaction. The system reaches into the background quantum fluctuations, a space we can think of as Heisenberg's placenta, pulling virtual energy out of the vacuum to compensate for the sudden loss of flow. Second, we broke the symmetry of space. The photon was spat out as a continuous wave, and we abruptly pinned it to a single location. The particle's forward momentum cannot just disappear. It has to go somewhere, so it physically materializes as a phonon. This diagram shows that kinetic transfer. A phonon is a literal, quantized vibration. When the photon's momentum hits the mirror's crystal lattice, it gets absorbed, causing the grid to shudder and radiate heat. Finally, we broke the symmetry of phase. The electrical charge of the system must be preserved. A photon has zero charge, and cutting it forces a local error in the field. Since it cannot create charge to fix the severed identity, the universe smears the information of the photon non-locally across the entire vacuum. Heat and vibration are the energetic echoes left behind when potential is forced through the needle's eye of the present. Matter is a dense concentration of these physical scars, occurring trillions of times per second. If reality's foundation is timeless, why do human bodies age or planets rotate? These macroscopic effects emerge from the sheer density of these symmetry breaks. We can view the universe as a swarm, an instantaneous, non-local network. In this system, every particle interaction is a cut that generates a tiny amount of physical friction, or scar tissue, like the phonons in our mirror. What we perceive as linear time is the resulting drag. It is the frequency at which billions of these quantum cuts occur across the network. We experience a sequence of events because the sheer volume of these interactions creates a measurable delay in the field. A black hole represents the most extreme truncation of these cuts. Here, the density of interactions is so high that the sequence of events, the very progression of time, eventually reaches a standstill. At the event horizon, the lag disappears. exposing the raw, timeless zero axis underneath. The distance between ourselves, each other, and the galaxies above is a product of this systemic drag. We are active nodes in an instantaneous structure, experiencing time only because the universe is continuously fracturing its own perfect symmetry just to manifest as physical reality.